Welcome back, OS enthusiasts, to another exciting episode of Operating Systems Crashcast. I'm your host, Victor, and with me as always is the brilliant Sheila. We're currently in Season 1, exploring the overview of operating systems, and today we're diving into Chapter 1, Section 1.4, Operating System Structure. Sheila, are you ready to unravel the architecture of these complex systems?
Absolutely, Victor. I'm excited to explore how operating systems are structured and organized. Before we begin, listeners, if you haven't checked out our previous episodes on what operating systems do, computer system organization, and computer system architecture, I highly recommend giving those a listen first. They'll provide a solid foundation for today's topic.
Great point, Sheila. Now, let's kick things off with our quiz question for today. What type of operating system structure separates the kernel into small, well-defined modules? Keep that in mind as we explore various OS structures today. We'll reveal the answer at the end of the episode.
Excellent question, Victor. To set the stage for our discussion, let's briefly cover some fundamental concepts. An operating system structure refers to how its various components are organized and how they interact with each other. This structure can significantly impact the system's performance, flexibility, and maintainability.
That's right, Sheila. Over the years, several approaches to OS structure have emerged. The main ones we'll discuss today are the monolithic structure, layered approach, microkernel, and modular approach. Each has its own strengths and weaknesses, and understanding them is crucial for anyone interested in operating systems.
Let's start with the monolithic structure, which is one of the oldest approaches. In this design, the entire operating system runs as a single program in kernel mode. Victor, can you explain what that means for the system?
Certainly, Sheila. In a monolithic structure, all OS services are tightly coupled in a single large kernel. This means that every system call, I/O operation, and hardware interaction happens within the same address space. While this can lead to efficient performance due to minimal overhead in communication between components, it also has some drawbacks. For example, any bug in one part of the system can potentially crash the entire OS. A real-world example of a monolithic OS is the original Unix system.
That's a great explanation, Victor. Now, let's move on to the layered approach. This structure organizes the OS into a hierarchy of layers, with each layer building on the services provided by lower layers. The key idea here is to separate the OS functionalities into distinct layers, making the system more modular and easier to debug. However, defining the layers and their functionalities can be challenging. An example of a layered OS is the operating system, developed in the 1960s.
Excellent point about the challenges, Sheila. Now, let's talk about the microkernel approach, which takes modularity to the next level. In this structure, the OS is divided into a small core kernel that provides only the most basic functions, while other services run as separate processes. This design improves flexibility and makes the system easier to extend, but it can introduce performance overhead due to increased inter-process communication. The Mac operating system, developed at Carnegie Mellon University, is a prime example of a microkernel-based OS.
That's fascinating, Victor. The microkernel approach seems to address some of the issues with monolithic systems, but as you mentioned, it comes with its own trade-offs. Lastly, let's discuss the modular approach, which combines some aspects of both monolithic and microkernel designs. In this structure, the kernel is composed of modules that can be dynamically loaded and unloaded as needed. This provides flexibility similar to microkernels while maintaining the performance benefits of monolithic systems. Modern versions of Linux use this approach, allowing for a highly customizable and extensible OS.
Absolutely, Sheila. The modular approach has gained popularity in recent years due to its balance of performance and flexibility. It's worth noting that real-world operating systems often don't strictly adhere to a single structure, but may incorporate elements from multiple approaches. For example, while Linux is primarily modular, it still retains some monolithic characteristics.
That's an important point, Victor. OS design is often about finding the right balance for specific use cases and requirements. As we wrap up, Let's recap the key points we've covered today. We discussed 4 main OS structures: monolithic, layered, microkernel, and modular. Each has its own advantages and disadvantages in terms of performance, flexibility, and maintainability.
Great summary, Sheila. Now it's time to answer our quiz question. What type of operating system structure separates the kernel into small, well-defined modules? The answer is the modular approach, which allows for dynamic loading and unloading of kernel modules, combining the benefits of both monolithic and microkernel designs.
Excellent! I hope our listeners found this exploration of operating system structures enlightening. Remember, understanding these structures is crucial for anyone working with or studying operating systems, as they form the foundation for how these complex systems function and evolve.
Absolutely, Sheila. That brings us to the end of today's episode. Thanks for joining us on this journey through the architecture of operating systems. If you enjoyed this episode, don't forget to subscribe to Operating Systems Crashcast for more in-depth discussions on OS concepts. Until next time, keep exploring the fascinating world of operating systems.